All right, this is your favorite teacher, Mr. Harper. And if I'm not your favorite teacher, then you need to change your favorite teacher. But we're going to look at literal equations, and literal equations basically just means that my equation has a bunch of letters in it. And it can have numbers, so you can see here I have a 2, okay? So it can have numbers, but in essence we have a lot of numbers. And you think of literature, you take literature class, the literal has to deal with, the letters part of it, okay? And so what I have found is a lot of students struggle with how to solve this. They see these letters and they get anxious, or they forget, the rules to solving an equation. So what I would like to do is kind of show you a method that may help you solve this. So for instance, let's look at this equation, okay? This is a literal equation. You've got E times x plus 2 times y equals z. And again, my handwriting's not the best in the world, but I think this is, you can understand this. What I want to solve for here is my x. Okay, so that's what I'm going to be trying to isolate. Remember, isolate means to get by itself. Okay, so I'm going to try to get x by itself. And so a method that can help you is that anything that is not your variable, and any term that does not have your variable in it, you're going to replace with a number. Okay, so for instance, I'm going to go ahead and write a different equation over here. Okay, so for instance, instead of e times x, I'm going to make this 5 times x. Okay, so again, I'm just replacing the letters, so the letter e with the number 5 plus, okay, I'm going to replace this whole term with a number. Okay, so let's say 10. And then I'm going to replace z with a number. Let's say 20. Okay. And then what I'm going to do is I'm going to solve this pink one over here. And I'm going to do the same thing over here, except with the letters. So for instance, if I look at this and I say, okay, how would I solve this equation, this pink equation here? I would be like, okay, well, the first thing I need to do, okay, is x is being multiplied times 5. Okay, and then it's being added 10. So, and again, remember, kind of the socks and shoes, the last thing I put on is the first thing I want to take off. So I'm going to take off plus 10 by subtracting 10. Okay, so that goes away. And we're left with 5x equals 10. Now, before I keep going, I'm going to do the same thing over here. Okay, so here I subtracted 10 from both sides. Okay. Here, I would do the same thing, except I don't have a 10 here. I have a 2y. So instead of subtracting 10, I'm going to subtract 2y from both sides. Okay, I'm just kind of following the same steps I would do if these were numbers, except I'm writing the letters. So here, these cancel out, and I'm left with e times x equals, now if you look at z and negative 2y, these are not like terms because they have different variables. Okay, so we can't combine these. We just have to write this out. So we have to write this out. Excuse me, that's a bad z. All right, it's z. That's not too much better, but that's okay. Minus 2y. Okay, so again, I'm just taking the same steps I would take here over here. Okay, I'm gonna switch colors again. Let's get this red. All right, so if I'm looking over here at this equation, I now have 5 times x equals 10. To get rid of a 5 times x, I divide by x, okay? Or divide by 5, sorry. Okay, and then we cancel those, and we get x equals 2. All right, now I'm going to do the same thing over here, except instead of 5 times x, it's e times x. So I'm going to divide everything by e. And again, I'm going to divide this whole thing by e. That cancels, and I'm left with x equals, z minus 2y. I'm trying my best to do a good handwriting here. All over e. Okay, and this would be the solution to solving this literal equation for x. Okay, and again, this does not look any less complicated than this up here. But that's with a literal equation, you're not necessarily simplifying it so much as you are trying to get one of the variables by itself or trying to isolate a specific variable. I think of it here, it looks like we did a lot of simplification and got something that's a lot smaller than what we had up here. Whereas here we can't simplify because we have a bunch of letters, okay, none of which are like terms. Sometimes there are like terms, but in this case none of them are like terms, so we can't put them together. So really it's just kind of rearranging, okay? But this would be the answer to that little equation, and hopefully that helps. It helps some people to go again, write an equation that's exactly the same except with all the variables that are not the one you're looking for replaced with numbers, and then solve that way. And sometimes that can help. All right, hopefully that helped. I'm gonna go ahead and stop the video, and then I'll make some more later.